Alright, in this video we're going to look at analyzing quadratics. So you're going to be given a quadratic, but I'm not going to tell you how to solve it. You're going to need to decide how to solve it. Well, in this section on Blackboard, I've also included the video where I take you through the different methods of solving and how the discriminant will tell you what's the best method to solve by. So you might want to view that video. It's called Using the Discriminant to Decide the Method to Solve by. So that might be good viewing for you. I'll be referring to this sheet as we move through here. Okay, so in order to do that, we're going to ask you a series of questions, and eventually these will be the things that you'll just keep fresh in your head as you are trying to decide how to solve. You won't necessarily go through this, actually answer these questions every time. However, there will be a couple test questions where you have to do that. Okay, so first we start off with evaluating the discriminant. So what is the discriminant? That is b squared minus 4ac. So on this problem, b squared, well, this is a, this is b, this is c. So this is going to be negative 5 squared minus 4 times a is 1, times c is 4. So negative 5 squared is positive 25, minus 4 times 1 is 4, 4 times 4 is 16. So 25 minus 16 is 9. So 9 is your discriminant. Okay. Now, the next question we ask is state the number and type of solutions. Well, that comes from this chart on yesterday's assignment. Since our discriminant is positive, we're taking the square root of a positive, so that's going to be 2 real solutions. Okay. How many x-intercepts does the graph have? Well, we talked about yesterday 2 real solutions. The graph of the parabola will cross the x-intercept twice, so you'll have 2 x-intercepts. Okay. Can the function be factored? Well, let's look at the other side of the sheet. The other side of yesterday's note sheet. We had a couple situations where we know factoring was possible. It could be factored if it was a positive square number. Okay? Or it could be factored if the discriminant was 0. What is our discriminant? It's positive 9. That is a positive square number. So this can be factored. Yes. How do we know? Because the discriminant is a positive square number. Okay. So let's keep moving. So we know we know it does factor. Now, would completing the square be a good option? Okay. Well, to decide whether completing the square is a good option, we need to look at the original quadratic. Now, the quadratic here has a 1 for the value of a, but b is an odd number. Now, if you recall from the homework assignment, and this might be a little tough to see, when we did the homework assignment by completing the square, all of these numbers for b were even. Okay? Except for problem number 24, b ended up being an odd number. And when we got an odd number, we got fractions. Fractions are bad, so we want to try to avoid fractions. So the only time completing the square would be a good option is if a is 1 and b is even. And we don't have that in this case. So this would be no, because the b term is odd. Okay? It's because the b term is odd. Okay? So what's the best method to solve by? Well, if it factors, factoring should be the best method. So factoring is your best method. So now let's write the problem and let's solve it by factoring, because it says we should now solve. So there is no greatest common factor. So since there's three terms, we should use opposite of FOIL or guess and check. First term times first term gets you first term. So those got to be x. Last term times last term is positive. So they have to be the same sign, but since the middle term is negative, they should be both negative. Factors of 4, they get you 5, 1 and 4. So now what are your solutions? This x minus 1, that gets you x is positive 1. And here, this gets you x equals positive 4. So you can see we have two, You can see that we have two real solutions, because this was x minus 1, x minus 4. And two real solutions, and that's what we expected. Now, if we look at this and we plug this equation into our calculator, let's look at what happens. I'm going to replace this 0 with a y, and I'm going to plug this into y equals x squared minus 5x plus 4. And if I hit graph, look at my x-intercepts. Looks like that's positive 1 and that's positive 4. Well, let me go to the table of values. What happens at positive 1 and positive 4? Well, positive 1, y is 0. Positive 4, y is 0. Well, if you're on the x-axis, your y value is 0. So that's why those are x-intercepts. So from your graph, you can see your x-intercepts are your actual solutions. Okay?